and there was a box. Where's the box?
Right here? There's a box of brains in there?
Yep.
I guess.
Oh, they're in here? They're in here.
Oh, they're in there. Okay.
Well, yeah,
Okay.
let's go, yeah. That's
Right. Okay, so in the front here, obviously the dura. So this is the dura, obviously. This is the tough
The dura mater.
The dura mater, right? It's very tough, fibrous connective tissue. In the front, it'll always be kind of ripped, so it's very easy to cut, or you don't even have to cut, obviously, most of the time. But the way to start the cut is to cut around the cerebral hemispheres, like that. Okay, so let's do that. Here's the forceps. I would start with like the midline here. What kind of forceps are these?
Not
So,
very good.
I just would slowly, so you don't cut too much. I don't know. There you go. So I cut actually some of the brain. Usually, it's better to use the scissors, to be honest with you.
Everyone wants the scalpel so they can play ER.
Mm-hmm.
I'm not going to cut the brain up with scissors. Scissors are better, though, for slicing
These
a layer. Like
scissors are really not good. They're so big.
Yeah, those don't really even look like dissection scissors.
No, I don't think they are. I think there's a first grade class somewhere that's missing their scissors.
They're lefties and they're righties.
Oh, no, actually, I'm sorry, fourth grade. If it was first grade, it'd be those little plastic
Safety scissors.
safety scissors. Oh, man.
Cut.
Very nice.
Cut. Like, try to, like, really
Expose it.
expose, like, really make the cut all the way down
Yeah,
here.
take that.
So, do this thing first. Both sides, obviously, and cut in the midline. Right. And try to squeeze those.
Maybe if you turn it around, the pointier, the topper one is sharper.
That's a good point, but then you can damage more of the... Well, let's just try it. I'll be a good sport and listen to you as
Well,
much
it's
as...
just a suggestion.
As
I'm
much,
not,
as much as I hated it. I'm just kidding.
Is there a difference here, how that's wider and thicker than the sides? Is there a different, like, connective tissue or something there?
Oh, you mean right here?
Yeah, how they look like a band.
That's where the sinuses are, like where, a lot of this...
nerves.
well, lots of the cerebrospinal fluid
okay.
will go through here, and then it'll be highly vascularized, where, if the cerebrospinal fluid reaches a high enough level, so if you were to open right in between here, you actually see there's a color in there, and that's primarily from the blood. Obviously, this has been perfused, so you really can't see any blood vessels at this point. But see, it looks darker in there,
yeah,
right?
it does on that side.
Right, so that's where all the blood vessels are. Okay, let's do that.
Because the sinuses go through there, you said?
Yeah. For this, the arachnoid villi, they call them. Okay. Okay, so we freed both sides in there. And what I would do is then I would cut this very thick connective tissue completely like that on both sides, and lift that.
And that's just more of the dura mater? Is that
Yeah, that's just pretty much more of the dura mater. Okay. And so you just then lift this, and you can hold.
nice.
Okay, I'll just use both. If you want to use your hands, you can split the brain like that. And then what you need to do is go on the sides, right? Where this was cut. All right, so we're gonna
It's
cut
okay.
more of that there,
She
and then make an incision like about right there. Cut that dura in there. Okay, and then you can just peel it off. Okay, so you
Peel off the rest of the dura?
Make sure that you go all the way
You gotta
deep
get
in here,
inside.
right? You got to get inside there and
Yeah.
cut all that connective tissue.
There's a
Okay.
little strip of it.
Right,
that
so
runs
see,
underneath
like
it.
that is free now
Yeah.
off the brain, and then you can just lift that and completely peel off
There you
everything.
go.
And do the same thing for this side, make the incision right there. Okay.
And that's the cerebellum in that rear half, right?
Right,
The rear
that's
quarter
exactly,
of it.
that's right.
That's what I thought.
That is the cerebellum right there. Okay, so you know, you've freed a lot of the dura
There.
outside of the brain now, like you can just peel it on both sides. Okay, so now on this side, when you turn it here, this is where it gets kind of tricky, because you have lots of cranial nerves that hopefully you would try to like save,
Yeah.
right? So I'm just gonna cut through that as well. I'm gonna see like there's some. I can see. I think that's the. Oh, that's cool. Okay, let's just see. Okay. Alrighty. So you can actually save some of the arachnoid motor. See, that's the arachnoid motor right there. You see
Oh,
that
yeah,
layer there?
arachnoid motor,
Yeah.
yeah.
So if you can actually, you know, if you're able to see any of the membrane in there, that's the arachnoid motor. Pia motor, you're not going to be able to see it. That's
the
completely
thinnest,
like, yeah, the thinnest. It's really right next to the brain. Bill, did you have a question, or are you just looking?
Just watching.
Yeah. So then, you know, just make sure that you clean it up and you be slow. See, here you have some of the cranial nerves right here, and that's part of the probably accessory nerve that starts at the medulla. Medulla, you know, is just like where the yeah, it's part of the
Yeah.
brainstem, obviously, where the bump starts, and the pons are up here. They're kind of whitish in appearance. All right, well, we'll go through all the parts in a little bit, but you just make those incisions like that. And, you know, take your time. Obviously, there's no rush. Just take your time, make it fun for the students. The real idea here is that they see the texture of the brain. That, you know, the gyrus, the sulcus, those kind of things.
Probably gonna sit where you're sitting now, and as many students as they want can just basically line up around.
So here's, you know, here's like we've saved actually a bunch of nice cranial nerves in here.
Oh,
Okay, and then you can look.
that's a cranial nerve, eh? Wow, it's
Yeah.
big.
So
That innervates the face.
no, I think this is the accessory nerve. Notice that
Uh.
it has all these tiny
Okay.
connections directly, and it's called accessory nerve for a reason. There's debate over whether you can call it a cranial nerve because cranial nerves really mean you know, the brain, in other words, not the spinal cord.
Yeah.
And this is mostly in the spinal cord,
Oh,
so
okay, I
that's a
see.
really nice one.
Got it.
That you can see. The facial nerve is way up here. This, you know, like right by the pons. And
Oh,
actually,
I
I've
think I
already
see.
severed it,
Yeah.
and it actually, you know, like let me just see on the side. Yeah, I've cut a lot of it. So this is the facial nerve, and goes all the way down here.
Okay.
So it's going to be really hard to save the facial nerve. All right. So before you cut this, you know, like for example, I want you to tell the students, okay, this is, you know, the dura mater. Below it is arachnoid mater, which you really are not seeing it in this one because they're completely attached to one another.
So there's actually two layers, the outer facing and the inner
There's actually
facing.
three.
There's
Three.
three, right? So
Dura is the
the
one.
periosteal layer, you know, of the dura mater, there's a couple there.
Okay,
So essentially, the arachnoid mater is the one that is kind of loose connective areolar tissue, where there's a lot of fluid in there that bathes the brain around, and so also immune responses can go through there because it's loose connective tissue. The dura mater is all fibrous; it keeps the brain all tucked in. It's very
Okay.
nice. So I think all you want them to understand is that there's a dura mater,
mater.
arachnoid mater, pia mater.
Right.
Right
And
next
the
to
pia
it.
mater they won't be able to see.
Yeah,
It's
the
the
pia mater
softest
is the
one.
one that you're not going
It's
to be
very
able to see.
thin.
It's very, very thin, yeah. So here, for example, that's your
yeah.
arachnoid mater. You can see
I
some of
like to
that.
put in my exams, which of these is not a layer of the brain? Dura mater, arachnoid mater, pia
Right.
mater, alma mater.
Okay, so sheeps are really good to identify the pituitary gland. The pituitary gland sticks out right below the optic chiasm. So this is the optic chiasm. This is the optic nerve that goes to the eyes.
Yeah.
All right, it's very well, so it has a lot of fascia. And remember that the retina literally arises from the brain tissue,
Yeah.
right? And so, you know, it's just an extension of the brain, if you will.
Mhm.
Huge
Massive
cranial
cranial
nerves,
nerves,
yeah.
yeah.
Right. The pituitary gland is right below the hypothalamus, and it's like this bulbous area here. It would be really hard to cut all the dura without actually snapping the infundibulum, which connects the pituitary gland to the brain.
Okay.
But it's the little ball right there.
This is the ball
Yeah.
right there, and it's right below the chiasm here.
Yeah.
Okay. So when you're cutting around here, you know, like you are definitely,
Risking damaging.
yeah,
the-
you're not going to be able to like see, like if I lift, notice, if I lift this here,
You'll see nerves. Yeah.
infundibulum is very thin stalk that connects to the pituitary gland. Can you see that, Bill?
But isn't the pituitary gland below the hypothalamus?
It is below the
I think,
hypothalamus, yeah.
Are they connected via that?
Via the infundibulum, yeah.
Oh,
yeah.
so the hypothalamus is
Right.
actually, because I don't think that's how
So
it's
remember,
integrated, is it?
anterior pituitary is the one that is pretty much considered like
The
it comes
endocrine.
from the roof of the mouth. It is the endocrine,
Right.
but the posterior pituitary is the one that is called neurohypophysis because it's just brain coming
Right.
down.
It's, yeah,
So it's half
integrated
of
by the hypothalamus, it has nerves running down, I
Right.
remember. But I
So
was
the
just-
facial nerve we already cut, and like we've done major damage, and the facial nerve was connected right here where the pons are. Maybe on this side we can save the facial nerve. See, you know, there still has connections there.
Yeah. I think
That's
hard to
the-
see.
That's okay. Well, I'm gonna try to cut like through here. These. Okay, these are so small.
That's all Dura there? What you got?
That's all durable.
Wow. It's thick.
So Brian's not here right now, but when he comes in, do you want an overhead TV camera put in?
TV camera.
Like a,
You can
Hook
put
up
a
to the
camera
elbow or
that you
something?
can dissect
Yeah.
under the
Oh,
camera.
I didn't know that
And
we
have
had
the
that
students-
thing. That'd be awesome,
That'd
actually.
be cool.
Okay.
Because
Yeah.
then you wouldn't have all the students like trying
Crowded.
to look at exactly.
You could still, well, you could still probably have the most hardcore students crowding, but you can
But-
have everyone else seeing.
Or
it.
you can have one brain for the students to like try to cut like
Oh,
part of the
God.
dura, some, you know, if you wanted
It's
to.
gonna make a mess.
Anyway, but you don't have to. I'm just saying.
I don't know
Yeah.
about that. I mean, like,
Yeah.
well, if we had more brains, I'd be down
That's
for
true.
that.
Okay.
But we
Okay.
have. only so
Here we
many.
go. That's all the dura there. All right.
Amanda, will you send this to us so we can review it?
Ah,
Yeah.
dude,
I'm gonna
totally
wanna read it. I'm gonna wanna read it and go
I'm
back
totally
and-
gonna just go.
I'm totally stealing your notes when we're done.
All right. So like I said, I'm going to send PowerPoints with, you know, like images of the sheep brain, and I'm going to put arrows
Oh,
for
okay.
every part of the
Oh, okay.
sheep brain that I want you to be able to like tell the students.
students,
So,
okay.
you know, you need to know at least when I cut the sheep brain in the practical, you should be able to tell the frontal lobe, parietal, temporal, you know, simple things like that.
Cerebellum.
Right. Cerebellum, obviously, and then medulla oblongata, and some of the cranial nerves that are very easily visible, like the optic, the olfactory. These are the olfactory
Oh,
bulb.
those are olfactory nerves.
So these
Okay.
are the olfactory nerves, and they go all the way to the olfactory bulb.
Yeah,
Okay, they have actually huge tract for the olfaction.
I mean,
of
that they
course.
smell
Most
better,
an-
yeah.
Most animals.
Yeah, absolutely.
Yeah, the more developed that part is, like a crocodile, if you look at its brain, it's like whoa, for the olfactory
It's
part.
pretty
too.
much, yeah, olfactory, yeah. Okay, so this side is pretty much like gone as far as the facial nerve goes. All right, so, okay, shoot. It's gonna be impossible to save the facial nerve, so don't even bother with it. So just lift it,
Yep.
all right?
Those are,
So-
you can see
Those
the
are the
remains of
nodes,
them, though, right?
yeah.
right? So there is the infundibulum for the pituitary, which is gonna be cut right there, you know, like.
Is the outer one the facial nerves then?
Yeah, I think those are the.
Those most likely are the, well, hang on a second. That could be,
Well, those are the things you cut, right? When we're saying
oh,
facial nerves
shoot.
could be saved.
You know, I'm having a hard time to know like where they are. I think those are the, dang it, I've cut
Well,
them.
here, look at
Those
that.
are the abducens nerves.
Megan, here's that.
That's the abducens nerve.
Oh, look at that.
That might have it.
Okay,
That's
so
a-
I lifted,
I won't let you-
so the infundibulum stalk, you know, like the thin part here, that's the thin part. And right under, you know, inside the dura here, that's your pituitary, okay?
It says.
It's really nicely
Oh,
wrapped
wow.
around. with that. Okay, so,
Wow, yeah.
yeah.
You can really see it.
Yeah, fine. Can't
All
see
right.
that. Thanks.
Usually I get a nice pair of oculomotor neurons, oculomotor nerves. I think that's the oculomotor on the side here. But you may not be able to see it. Okay, a few things that you should be able to tell them. I think, no, okay, so this is the abducens nerve right here, right below the pons. That's the pons, okay? Let's just stick with the easiest one to identify, because I don't want you to actually deal with cranial nerves on the
Yeah.
sheep at all, because I think it'll be difficult.
It's hard enough on people.
I know. So let them do the labeling on the brain. The sheep brain will just go with the things that we can easily identify. All right, pons, medulla oblongata, cerebellum, right? And these are the cerebral hemispheres. Obviously, they should be able to know that at the back or abutting from the cerebellum, that's the occipital lobes, parietal lobe here, and like way out here, you can just say that that's the frontal lobe.
So that's the temporal lobe.
And the temporal lobe are below here.
It's very similar to ours.
Right.
Yeah, it's so similar to ours. One thing that you could also point to them is the midbrain. So notice these two bumps in here. These are the corpora quadrigemini, they call them. Quadrigemini is like quattro, right? 4 bumps. 1, 2, 3, 4, right? Superior colliculus. And this deals mainly with visual reflexes. And the inferior colliculus is all about auditory tracking, right?
Got it.
Information for tracking, like sound, where it's coming from.
Do we have those also? Same thing?
Oh, we have the same thing, yeah.
Okay.
We have it, exactly. So the sheep brain do too. And way under, way above the superior colliculus is the pineal gland. The pineal gland is that little structure,
Yeah.
all right? It's just right
Yep.
there.
Oh, yeah, beautiful. You can see right there. They used to think that was where the human soul was stored because it was the only part of the brain that wasn't.
Oh, is that right?
Yeah,
Huh.
it wasn't the only thing that was magically paired somehow.
Oh, that's a very neat,
So they thought it was just one in the middle. They thought
right.
that was where the human
So
soul
one more
was.
time, let's notice the midbrain, all right? So the midbrain has these 4 bumps, 2 in each side, superior colliculus, inferior colliculus, and way, above the superior colliculus and the midline, that's your pineal gland. That's what regulates the circadian rhythm. And here you can notice some of the arachnoid motor too, like a very thin membrane left. You see this thin
Yeah.
membrane? Actually, the thin membrane that you see above here,
Slick.
that's the arachnoid motor.
Yeah.
Okay, pia motor, you're not going to be able to see it. Okay? So you should be able to tell them, all right, these are the gyrus, the bumps, and the sulci are the grooves in between. The fissure is a deeper sulcus, if you will, and that separates the 2 hemispheres,
Only a few, yeah.
right? Right in
Okay.
between here.
That's the,
And that's where we're going to cut in a little bit. 2 cranial nerves that you can spot very easily on a sheep brain, obviously, are the optic and the olfactory. Okay?
And those are the temporal, the 2 bumps at the
These are
bottom?
yeah, those are the temporal. They have also a central sulcus, but it's really hard to know where the central sulcus starts in
yeah,
a
you
sheep
can't
brain.
tell here.
So we're
The
not going to
central
bother.
sulcus in humans, it's pretty easy. Just
Right,
runs right,
right,
here.
right,
but
right. Okay,
sheep
so
is-
distinguish it for them, like spinal cord is down here, the tail, and medulla oblongata is where it, you start having these expansions, all right? Okay. So how to cut in the middle, you can do it both ways. You can go either directly here, and it's really hard sometimes to make the cut smack on the middle equally. But so just try to do your best. Cut the cake in the middle. I'm sure some people that have worked with sheep brains a lot, they would be able to do it better than me, but okay.
Oh boy, look at it, goes right through it.
Yeah.
Snip, snip.
Snip, 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 and
Beautiful.
Okay.
Oh man, that is so
Okay.
attractive. Look
okay,
at that.
okay.
Cut right through it. And it's like cutting broccoli.
All right, cutting the broccoli. Broccoli is the cerebellum there, right?
Yeah, you can see it, beautiful, oh man.
Okay, so cool. We did that. That's all good. All right, few things that you need to tell the students that are most visible. Cerebellum, and cerebellum has this arbor vitae. Arbor vitae is the white matter that branches out just like a tree.
That's myelinated, right?
Right, that's myelinated. Very good point. And then you have the gray side. So you can tell them like you have two things in common between a cerebellum and a cerebrum, and that's the cortex. They both have a cortex, which is this gray outside the brain tissue, and that's all cell bodies, right? That's all neuron cell bodies. Same thing for the cortex. The cortex obviously has you can actually make another cut if you want to for the brain to like really show, like especially at the tip of one of these. What I would do is I would just cut it like that. So
Oh, wow.
Like that.
Look at that.
do that, and then
Ooh,
you
we
can
don't
say
do that very much. Look at that, show the camera. Oh, man.
right. So that's the gray matter, the darker appearance in there. That's where all the cell bodies are, and this is where all the tracts are, all the axons, the myelinated stuff. Yeah, that's why
transferring information from
right.
part to another of the
that's
brain.
why it appears
That's the post
white.
office.
It has a white appearance
That's
to it.
so awesome.
Okay. So do the cut of the sheep brain. Take your time to like really cut it slowly so they can kind of absorb and see what the brain looks like and should be. I mean, that's kind of my goal, because a lot of it is going to be covered in the lecture.
So that bottom part there, that's
All right.
So cerebellum had
Okay,
the
so
cortex
let's-
in
right.
common. What else did it have in common?
So cerebellum has the cerebellum and the cerebral hemispheres have the cortex in common, right? They have this gray matter, which is primarily neuron cell bodies. So kind of distinguish to them. I'll say like, here's a neuron. What do you find in the cerebellum cortex? It's the body, this part.
It's gray.
Look,
It
they actually made it
Gray.
gray. That's a perfect example.
And then the
Right,
bottom is
and
And then
then
there's the white matter.
the
Yes.
white matter is the
And that's the
myelinated.
white matter transmits information from one part to another,
Right.
and the gray matter, that's
Yeah.
the actual neurons that are hooked
Yeah.
into each other, and they're dendrites, and they actually transmit. They perform the calculations for various kinds of cell circuitry.
Right.
And what's the second thing they had in common?
So like I said, I think I said one thing about what they have in common. Obviously, they have cortex and they have also the white matter. But the cortex is the outer layer of the shell. Okay, on their outer layer of the shell, as you can see it in here. So if we were to just separate these, right? We're talking about the shell, right?
Yeah.
All the shell. That's all where the gray matter is, and that's called the cortex.
That's why it's
Anything that you find inside, let's say the cerebral hemisphere, if you find a nuclei there that looks like a gray matter, those are called nuclei.
Okay.
They're also the same thing, the same gray matter, which means
It's
cell
just
bodies, right?
inside.
But it's islands of group of neurons. Okay.
So it would be like somewhere,
Yeah.
well, you can't see it,
That's
but
why-
Well, no.
somewhere
So
in
there is.
here.
I think there is another kind of brain that is cut cross sectionally.
And so you can see the
You
gray
can see
matter
the
that's
basal
inside.
nuclei. Yeah. Yeah.
So they say that this is
In
why
fact-
they say brain's more wrinkles, is means
Right.
you're smarter, because it's got more surface area to have that gray matter.
In fact, one half of the brain you can cut it all the way down here, and we should be able to see some of the nuclei that are in
Basal ganglia.
The basal ganglia.
Yeah.
That's right. Very good. Very good point. Okay, so the most visible things. Corpus callosum is this white area here. Okay, that's the corpus callosum.
Connection between the two.
Uh-huh. And this is the fornix right here. But I don't think you want to worry too much about the fornix. What I want you to be able to identify is the lateral ventricles. You see this opening in here? That's the lateral ventricle.
Yeah.
Cerebrospinal fluid.
Oh, okay.
That's where all the cerebrospinal fluid is.
It's floating, the brain's floating.
Right. And the brain inside, yeah, it's floating, it's having all the cerebrospinal fluid. How is it produced? It's produced by these so-called choroid plexus, and you see that? And that's dark. And the reason why it's dark in appearance is because there's a lot of blood vessels in there, and these ependymal cells, all they're doing, they're neuroglia cells, really. What they do is they filter the interstitial fluid into this space here, and that's your cerebrospinal fluid.
The ependymal cells are also
And what is the
stimulated.
dark thing called?
I'm sorry?
Choroid plexus.
Choroid plexus, right?
CH choroid.
You find choroid plexus in the lateral ventricle, and you find it on the fourth ventricle as well. I think in the sheep brain you might have a really hard time spotting that. I mean, so the fourth ventricle is between cerebellum, in the back here, and the pons. So it's the space in here. Really, you can't really see it here.
Depends on the
So that's very hard to see, to spot.
Maybe right there.
Yeah, so there is part of that, yeah. There's part of that. And usually you'll find a choroid plexus similar to that, you see? Yeah, it looks dark, yeah.
The ependymal cells
And
line,
so-
they actually line the entire ventricle, and they're also ciliated. They
right.
keep
And
circulating.
notice how it goes inside there too, like, so if you really pay attention,
Yeah.
right?
Oh, wow, yeah.
Yeah, so that's where the choroid plexus is.
Wow.
Simple as that. All right. Corpus callosum, lateral ventricle, choroid plexus that produces the cerebrospinal fluid is a very important one. Right below the lateral ventricles, you have the thalamus.
Yep, right up on top of.
And the thalamus looks like an O shape here, and just kind of have a mnemonic in your head that it's the operator that
Okay.
filters all this information coming from here that needs to go down
Looks
there.
like a scallop.
Or sensory information that comes from the eyes, from the optic chiasm, goes to the thalamus. The thalamus decides, is that important enough for us to calculate it? No, it'll shut it off there, or it'll send it up to the cortex. So it's the operator.
The thalamus, I would
Looks
also
like
tell
a
students,
scallop
I'd always tell the
looking thing.
students, the hypothalamus regulates the body, the thalamus regulates the brain.
Okay, good job. All right, that's right. Okay, so there's the optic nerve, right? It comes directly here, and it goes into the thalamus, right? And it goes in specific nuclei of the thalamus. Now, how do you know where the hypothalamus is? Hypothalamus is kind of an extension, usually, for this one, this brain. It's kind of like with the way we've cut it, but it's this area right here. It has slightly different appearance right here.
It's a different
see?
texture.
Yeah, you're
Doesn't
right,
texture?
stronger. Yep,
And remember what we cut in here when we took that,
you can see.
where we took that pituitary gland. Pituitary gland was like right here, right below the optic chiasm, right? So there's the optic chiasm. Right below it was the pituitary gland, and really pituitary gland is a continuation of the hypothalamus, which is this stuff here.
Okay.
Okay.
Epithalamus with the pineal
Epithalamus,
gland behind it.
yeah, was behind it, and the best way to look at to identify the
Pineal gland.
the pineal gland, thank you very much, because I was just running, is by looking at this angle here, right? And it's this structure right here. Yeah. Right, this structure right here.
There.
Yeah.
And that's an extension backwards from the epithalamus.
Correct. So there's the thalamus, epithalamus, and hypothalamus is down here. So it's below it, right? And
Awesome.
this is the midbrain, the superior colliculus, inferior colliculus, just like we looked at it before, right? The two bumps, the way you cut it. Superior colliculus, inferior colliculus, that's all good. And how do you differentiate pons from the medulla oblongata? Well, the pons look a little bit darker, okay? And medulla oblongata is right below it. And this striated stuff here, that's the cerebral peduncles. It's a continuation of the cerebral hemispheres, but don't worry about the cerebral peduncles. I don't
remember those.
Yeah,
I don't-
no worries
great
about
name,
those.
though.
Yeah.
Yeah, it's true.
All right. So distinguishment, right? Obviously, we talk about adult brain. You have cerebral hemispheres. You have the diencephalon, which is composed of thalamus, epithalamus and hypothalamus on this side. That's diencephalon. Midbrain, right? Midbrain is superior colliculus, inferior colliculus, and then brainstem and below here. Well, brainstem starts immediately below the thalamic structures. So
Yeah,
it's right, the
It
stem,
sits atop the
right?
brainstem.
This is the stem below here, so below thalamus structures, where you start with superior colliculus, inferior. That's all midbrain, all the way down to the spinal cord, and it excludes the cerebellum. So brainstem is anything below the thalamus.
The
Okay.
thalamus sits atop the brainstem, regulating information as it flows in.
Right. And I think that's all. I think that's all that's all, the things that you need to show them for the sheep brain. The dura mater, you want to make a point of that, and then the lobes, the cerebral hemisphere lobes, occipital, parietal, frontal, and then temporal, like way down here.
Awesome.
Okay. Did you guys want to see the cut here to see the basal nuclei? Hopefully, we'll be able to.
Oh, sure, let's give it a try.
Yeah,
See what we can
I don't know that we will be able to.
Man,
cut
look
it.
at it just go through that.
It's such a
Like
mushy.
the-
Have you ever had actually sheep brain?
No, I've had cow heart. That's really good.
I've had it in like taqueria, like.
Oh man, that's a delicacy in Peru. Oh man, cow heart is so good.
Okay, so.
Yeah.
Shit.
Oh, those are.
So,
No.
all right, no. So there's the caudate nucleus, and it's associated with the lateral ventricle. You see that gray spot there?
Yeah.
That's the caudate nucleus. Below here, then you'll have the thalamus, for example.
The other ventricle right there,
That you
right?
see.
The little one?
Oh, yeah, the one here, down here, yeah.
it's a continuation
Yeah,
of
the
the-
third ventricle, remember, it's associated all with the thalamus.
Yeah.
Okay, and it's just right below it here. You see?
Mm-hmm.
That's, all right, so third ventricle is, okay, lateral ventricle, third ventricle is right
We
below
should
it.
have a model of the ventricles somewhere around here. I think
Okay.
that's it there.
That's a very good point. I'm glad you brought that up. So third ventricle is right above the thalamus, and there's the choroid plexus. Lateral hypothalamus, right? The 1 and 2, which are from both
Where's
sides.
the first, second,
And the third is a common one.
the third one?
And then the fourth one is way down here, which you're not going to be able to really see it.
Okay.
Okay? And you know, so I just wanted to show you what a nuclei are. Obviously, those are islands of gray matter, especially around the ventricles. And those are called basal nuclei, right? If they're outside the spinal cord, if you have a group of neurons, cell bodies outside the spinal cord, those are called ganglia.
Yeah.
Okay. I think we're done with this, right?
Yeah, that's
Do you
cool.
guys want to practice, one of you guys, and tell me all the parts? I can just test you. What is this?
I
What
would
is
like
that?
to,
Yeah.
if I can just point